To the last video of this training program. Now in this video we are going to look at the main concept of this whole training program, the exploratory data analysis. Now I hope you have enjoyed this journey so far. If you have joined us, have been with us so far, and to learn all of the things, all of the concepts we have learned so far are going to be effective here in this exploratory data analysis. Also, I haven't sent this before, so as a member of this club, I would like to say that our channel has grown with a really great support from all of you guys, so kudos to that. And try to go down below, subscribe that channel, hit the bell icon, and also like the videos you have watched so far if you really did, because your support means a lot to us, and we'll be continuing this journey ahead if possible with a couple of more training programs or even some events. So let's move on to our last video, the exploratory data analysis. What is that? It's basically a process wherein you analyze your data, the data you already have. You try to perform some analysis on it. You try to perform some derivations about the insights it has to actually become capable of selecting the right qualities, the right features to decide your output or predict some value or tell something about someone on the basis of the data you have. Also, the exploratory data analysis consists of the part of visualizations. What do actually visualizations mean? So visualizations help you to identify several insights about the data easily by directly viewing those graphs, those visualizations. There are distributions, there are bar plots, there are scatter plots. So this all in all contribute to showing you how the data can be reflected graphically and how it can be easily interpreted by anyone viewing it. Now I haven't shared about the data visualizations video or about the libraries used in data visualizations because we couldn't get enough time for that, but hey, I'll be showing you a bit of how you perform the data visualizations as well. Now let's start it. So there are few steps which you have to always consider for the exploratory data analysis. The steps may vary on the basis of how your data is. So first of all, always you have to import your required libraries, and we have here NumPy, there's pandas, there's matplotlib.pyplot, that is actually plotting, that is visualization library. Then there's Seaborn, again a visualization library which actually enhances the pyplot charts in a better way. And then there's SciPy, which is again scientific Python, which we are not going to be using a lot, just for one simple example wherein we have to obtain Pearson's R, or as we say, the correlation coefficient. Now these libraries may not be familiar to you if you haven't actually tried it yet, but I bet you that if you try to just search them and explore them, you'll be obtaining much more information from its documentations rather than watching a video online. Now, if you know the NumPy, you have obtained your hands-on on the NumPy, you can easily shift to how SciPy actually works, because scientific Python is basically about more mathematical terms you want to use, more scientifically mathematical terms. So let's import these libraries at first. It's taking some time. Until then, let me show you what the second step is. The second step is to import the data set. Now, what is a data set? A data set is basically any file. It can be a database having the data, like SQL file, MySQLite 3, or anything like that. Okay, it can be PostgreSQL as well. There are several databases sort of files, right? There are several extensions for differing usage. And similarly, you can also import the data set as in .csv or xlsx. xlsx is basically your Excel file. CSV is basically again your Excel file with as an comma separated file. And our libraries are imported. Looks like it's a bit slow. Now let's try to read our data set here. Let me show you what the data set is actually about. So this data set, I hope it's visible. Wait. Okay. Now this data set is about the placements of students on the basis of several factors, as in for to look at if that student is placed or not. And there are several other factors considered, which can be considered here. There's gender, there's SSC percentage, there's SSC board, which kind of board the student was in. Then there's similarly HSC percentage, HSC board. Then there's HSC field of study. Then there's degree percentage. Then there's degree type. There's also work experience, if the student already has some prior work experience. Or there's some ETS percentage. I don't know what that was. Maybe you can figure it out. There's specialization, kind of specialization the student has gone through. Then there's MBA percentages. There's status, if that student is placed or not. And then there's salary. You can see there's 270k, 2.7 lakhs and stuff. And there are few not placed, having no salary over here. And these are few features of a student having placed or not. And let's see how to perform some data analysis on this data set we have. So to read a data set, we simply use the pandas method of .read. For here, over here, we have a CSV file, so we are reading it as .read CSV, and then just specify the name of the file inside the double quotes or even single quotes, because there's no difference between that in Python. So you can read a file this way, and you can even read other form of files. You can just, let's see what kind of files. Just let's press tab and try to see if we have any other type of files. Yeah, you can see there's read clipboard, there's CSV, there's Excel, there's feeder, there's FWF, etc. There's also JSON. Several people try to read data from the APIs, so that basically uses JSON file. There's pickle, SAS, SQL, as you can see. There's SQL table, there's SQL query, and so on. So for now we are going to use a CSV file. So let's import the dataset as a name placement df. Now let's try to check the first 5 elements of the dataset we have imported. To check it, we use .head method. You can see this is our data set, how it looks. For any person who is performing the data analysis, these are the first steps to take. To check on the .head, import your data set and check on the head of the data. The reason is to look out for if there are important features we have to take care of, or try to derive some insights inside your head, some raw insights about what we will be doing with this data, with the features we have, if we will be predicting some continuous variable or we'll be predicting about some categorical variable. Now the next step is to identify the features and columns. To identify it, let's see what the columns are over here for this data set, and there are all the columns you need. Try to look at their importance in the data set itself. If they are important to the data set, we'll be considering them more, or if they are not, we can simply remove them as well. And we can check for on the length of the data frames, columns, and these are all 15 features, 15 columns. Now you can also check on the D types of all the columns we have, and then there's all the numerical values here are float 64 type, and other categorical variables, that is gender, there's SSC board, there's HSC board. So these are type of object, they have object data type. Now I've spoken many times about categorical or continuous variables. So for those who are new to this or who just don't know this concept, I'll just speak out briefly that a categorical variable is basically a variable where it has some discrete values or only some possible values, maybe some limited 10 values, 5 values, and we can actually classify a variable as that particular value. So the values can be, again, they can be ordinal or they can be just pure categorical, and that's actually a bit of statistics concept, but I'm just trying to briefly tell you that a categorical variable here, if we look at this data set, there's SSC board, so there can be others, there can be central or state board. So these are three categories we will be considering for that board. So SSC B here is a categorical variable, while for the continuous variables that it has continuous values. So here if I take for instance let's say HSC percentage, so it is continuous variable because we have continuous values, differing values, which we have to consider to predict certain, or rather than saying predict, let's say to do or to perform some analytics on the data on the basis of that particular column, we have to consider it as continuous variable. We cannot say there is just 1% of 90%, then there's 2% of 91%, etc. So we'll just end up looking at a lot of such categories, right? And it's not feasible. So just try to get a basic insight, basic like common sense insight on that, if like what categorical column means, what a continuous column means, continuous feature means, and just move ahead. And we have to check always in a data set that if there are any null values inside it. Let's check it, and we can see there is no null values for all the features except for the salary. Now why did this happen is there are students who are not placed as well. and they have just an N salary, that is not a number. They have empty cell. If you look at our Excel file, okay, let's see, here is a empty cell. So this basically is interpreted as an N value in Python from the pandas. Now, as we can see, but that other variables do not have any N value, it means our dataset is totally clean. The salary having an N value is explainable. It is not because of the lack of values or anything like that. It's because, or say it's for a reason, and we know that reason, right? So we don't need any data cleaning over here. How did I actually obtain the NN values is by just using this is null method and summing up all the number of null values or NN values inside each column. Just write dot is null and as dot sum. Okay, now the next thing in this step is to remove the unnecessary and non-deterministic features or columns. Now in this data set, if we have a look at it, we don't need SN number because it basically is just index with starting from 1, so I don't think we need it, right? Then there's gender. Now, do we need gender? Do we actually need to look at how many male people were placed or female people were placed or so on? Now, as we are going to use the data set for predicting if a student will be placed or not ahead, like take for this consideration, I'm not going to show you the prediction by using some machine learning model or so, but try to consider that after you perform this particular analysis, you are going to predict if a student is placed or not, or predict his salary on the basis of these factors. So should we actually consider gender? I don't know. I don't think gender is of utter importance over here, so I'll be skipping on gender. And before I move ahead, I'm willing to tell you something, that in AI, in the field of data science and AI, whenever we deal with the data and we have to use the data to produce some predictions or insights about it, or take a decision based on the data, the data driven decisions for any company or any organization, or maybe for any specific person. To do that, we have to always consider the AI ethics. Now, what AI ethics are, or how they what are the rules and all stuff, I'm not going to explain them all. And basically, it's I recently read a post on that, an article that most colleges or even most of the training programs like ours itself don't offer enough insights about the AI ethics. Now, since we are not a big organization, but we'll be trying to keep our right path always. So, AI ethics basically focuses on deriving the insights, deriving your predictions on the basis of the data, but considering the cause as well. So there can be a possibility that someone may say that on the basis of this current data, if there are more students having the percentages of SSC, HSC, and say degree, MBA percentages low, and they're still getting placed and their salaries are high. Maybe if we get that kind of insight, a recruiter might think that, hey, maybe the student having more percentages like the qualities. Now, this doesn't happen in the real world scenario. Of course, someone scoring a good percentage will be considered, but it's a possibility we can't avoid. It is a possibility in the end. There is a possibility that some recruiter might just fire off some employee just based on this particular data we have obtained, the insights we have obtained on this data set, or maybe there is certain other data set saying that there is a particular performance based on employees particular records, and if employer gets to know that on the basis of those insights an employee is wrongly hired, he might fire him. Now this although doesn't happen in this real world scenario, we are already taking our risk, we are already considering that risk and using our data, or creating the insights of the data considering those factors. So we always have to consider that if we actually need a feature or not, if it will lead to certain wrong impact on the society or on anyone. Now this is an important thing I wanted to tell you about, because this is not told in most universities. As per the latest study, there was a report study wherein they said around just 15% of universities actually share this insight with students. This is actually one different course wherein they teach you the rules of data science and AI, wherein you shouldn't contradict the rules and regulations of AI. Now this is because I just wanted to share this information, to always be considerate whenever you try to create new projects ahead, or move on towards a great age towards the data science or AI. Okay, so now you can see, I think I don't need SL number, there's gender which I don't need in my dataset, then there's SSC board. I don't think I should be judging someone on the basis of if a student, if a person is from central board or state board or others, and predicting my values, or even the HSC board. Okay, so I'll be just removing these columns from my dataset because I don't want them to be considered. Okay, so we'll be dropping off these columns by using the dot drop method. If you have viewed my previous video of pandas, you might have gone through this function. You just have to specify a list of the columns and just specify the axis, where axis is equal to 1 for me right now because it is columns. Okay, now you can view the head having no unnecessary columns. Okay, now let's go with the next step, which is exploring the categorical variables. Now I've already explained what a basic categorical variable is. It basically has discrete values. So in this data set, in this particular data set, our categorical values are variables are, there's HSC field category. Where is it? HSCS, that is what kind of field a student opted for HSC. Then there's work experience, if a student has had some work experience or not. Then there's type of specialization, there's marketing and HR, marketing and finance, etc. And there's placement status, which is placed or not placed. Then there's type of degree, wherein there's science and tech, communication and management, etc. Now we'll have a look on them one by one. So to explore them up, let's create, or let's get particular columns for us. So we can access the particular columns of a data frame by just typing in dot and just specifying the name of that column, and I'm storing this in HSC. Then there's degree, there's experience, then there's specialization status, and you can just, for example, view one of it, and you can see what is HSC actually. It is a series, right? It should return a series because there's just one feature. And you can see this is how I've obtained all the columns I need right now, as in for the categorical variables. Now, to create or to look out for the unique values in each category, we have to write down, or say create a set of each series, so that we get unique values of each series, and just use the string. And yeah, so for each category over here, we'll be looking at the number of possible discrete values we'll be getting. So here's all 5 values. After executing, we can see the unique values in HST category are commerce, arts, science, and there's unique category for degree category. There's communication and management, there's science and tech, then there's others, then for work experience, yes or no. Okay, then there's specialization category, wherein there are 2 values, marketing and HR. Then there is other, marketing and financing. Then there's placement status, as not placed or placed. Now in categorical variables, there are 2 types of categorical variables again. The first type is binary classification or categorization. In that, basically we have just 2 categories for a categorical variable. For example, you can see here there's work experience having just 2 values, yes or no. There can't be possibly any other value, right? Then there's placed or not, there's 2 values again, placed or not placed. And the second type is basically multi-class categorization or classification. And again, you might confuse classification. What classification basically is to classify or try to categorize the objects we already have and create certain, let's not make it complex. Classify is basically categorize. Why am I telling this right now is because you might find a bit of difference between what a category is and a classification is. So classification is one of the methodologies to perform the predictive analysis, so predicting some values about the data using some new data. That is basically machine learning part, which we are not going to be talking in this video, or in fact in this whole training program. I'm not at all talking about machine learning, I'm just about data analysis. So over here we can see there's multi-class categorization, wherein I have more than 2 values or 3 values, or even there can be more values. Now let's try to plot some bar plots for our categorical data. Now the Seaborn library we have imported before has a method called as countplot. So countplot basically tries to plot the total counts of different categories inside the categorical variable we have. I mean, plotting the counts of each category inside a variable. So if I have HSC type, I'll show you. Okay, you can see this plot over here. So it basically shows the number of commerce students, the number of science students, the number of art students. You can just get a good insight on the comparison between these 3 fields. on the basis of count. So count plot is usually used for univariate data. You can also use some bivariate data. Okay, now I hope you know what univariate and bivariate data is. If you don't know, chill. Now we can look at the counts of each category. Now the next one is for category of degree, and you can see the insights that first of all, the HSC students, most of the HSC students prefer commerce over science over arts. You can see there's very less art students in the college. Then the type of degree most students prefer is about the communication and management. Then there's that is science and tech, and then there's others, SAT for science and technology. Then you can have an insight about work experience, so whether the students have any work experience before or not. And you can see around 60 to 70 people, around 70 people don't have some work experience, while around 140 people don't have it. And then this type of specialization, and you can say marketing and finance is more popular than marketing and HR. Then the employment status or placement status, and you can see around 140 plus people students have placed, and 60 around haven't been placed. So these are basic insights of our categorical data, just to look at which particular category has more popularity for that particular variable. Okay, this is often used in writing articles, reports about certain data set about maybe there is a possibility that I say the top universities of the world offer this particular program. I can say AI is growing, right? There are many universities accepting or having AI programs these days. So we can actually show the plots of number of AI students in the 2020. You can show similarly a bar plot, a count plot of the Mech students, the CSE students, etc. So it basically shows you, it gives you a raw insight about how the categorical data is going to progress. Now there is the next step, wherein we have to find possible conclusions from the categorical data we have without forming any basis of continuous data. So when I say without forming any basis of the continuous data, in the exploratory data analysis in real world, in reality, we have to actually form basis of the continuous data as well, as soon as we do this analysis about the categorical data. That is how categorical data affects a continuous variable, and that actually can be done using machine learning models. There are several classification algorithms or continuous based on continuous regression problems and so on. Although I am not going to discuss about it, I'm just specifying this, that even EDA consists of some machine learning part often, because we have to actually form some insights, some analysis on the part of how a categorical variable is affecting the continuous variable, or vice versa as well. For that, we often try to use models, we try to fit the machine learning models and try to look at some insights of the data. Now here we are going to just have a look at basic insights. So let's see the insights about students taking science, arts and commerce for HSC. Here I'm basically forming or getting the length of total students having science as a field for HSC, and you can do that by just specifying the data frame inside square bracket, provide the condition, that is the column having the value science. And similarly for the arts and commerce, we have looked at this in the previous video of pandas, is the same. Just have a look at the categorical values, and let's try to print this. You can see the total number of students who actually studied science as a subject for HSC are 91. Then there's arts at just a mere 11, and there's commerce at 113. And you can also try to print out our percentages of the data we have. We are simply using the percentage 100 into the number of science students upon science plus arts and commerce, summing up and then rounding that value to 2. I hope you know round function. And then using the string so that it can be printed as a concatenated string to the string we already have. I hope you understand these concepts. If you don't, try to go back to some previous videos and go to that particular part to understand it better. This is, even though this is really basic overview, this is really essential. Even if you can do this much and try to derive some more statistics about data, you might take the job of a data analyst. So even if it's not this easy, but this is the base, the step towards a data analytics field. Now we can obtain the percentages as 42.33, then there's 5.12 for arts students, then commerce students cover the most percentage, that is 52.56. And we can obtain similar insights about other data, categorical data, which we have as degrees. So you can see the science and tech are near about 59 students. There are communication management students who are at high stake 145, and other departments just 11. And you can also obtain again the percentages. And moving on, similarly for each category we have to do the similar task and try to derive some insights about how they may be affecting certain variable inside the data. Maybe if you just try to look at how you are proceeding with it, there is a possibility that the students who went through just science have better salaries, or maybe there are students from commerce who have better salaries or better percentages of getting placed. Although I'm not going to show how to do that here, but think about it, as whenever you try to perform the data analysis, these thoughts have to cross your mind, these ideas have to cross your mind as you do the basic data analysis. So if I say maybe the science and tech students, graduated students, have a more shot at getting placed than the other norms students, that is a possibility as well. So try to analyze that by yourself as well, whatever you think is appropriate according to your brain. Why I'm saying this is because this is like the data analysis is a bit of common sense combined with statistics and the Python programming as a tool. So here you have to walk through what's important and what's not, which would be a key performance indicator. What is a key performance indicator? This is a term used a lot in data science, KPI. What it means is that a KPI is basically a feature which performs as the best way to get your predictions right. So there can be multiple KPIs, multiple features, and so on. Now this is like a self-discovery part on your end, because I've just shown you how the tools work, how you can actually use those tools basically. Now as soon as you try to explore them yourself, you will get to higher levels of deriving right insights about any data set, not just any data set having just clean values. There may be a process called as data cleaning, which we didn't need for this particular data set, but for most of the data sets we have to do a lot of proper data cleaning, wherein we have to either remove NA and values we have. For example, over here we have the salary having some NN values, but in this particular case we are not going to remove those NN values for a reason, and the reason is that there is a status which says that the students are not placed whenever there is the salary is NNN. They are self-explainable. If you have data set wherein there are just random missing values, maybe I don't have some students degree percentage, some students HSC percentage, and so on, what would we be doing in that condition? Would we be directly removing that person's data from our data set, or would we be just replacing the NN values with 0, or replacing them with the mean or the values above or below them? Those are decisions you have to make while cleaning some data. If you are actually new to this, you might find this very obscure, because data cleaning is very like a method of common sense, and more than common sense, practicality. The more you practice actually on data cleaning, better you become. You have to do a lot of analysis or think about it. If for example I say HSC percentage here, if there's this percentage which is missing 68.00, it is simply NN. Should I replace it with 0? No, that doesn't make sense, because a percentage cannot be 0, of course, right? Can I remove that data particular row? I might think over it, because again, if I do that for every data I obtain NN values for, I might end up removing or decreasing my data set. The length of data set is of utter importance. Longer the data set, having more values, more different random values, more the insights I can derive out of the data set. So I should be again reconsidering if I should remove that data. Yes, if I have a data set of say 1 lakh values and I've just merely 10 to 15 values having the NN values, I might consider removing those 10 to 15 values directly, because it's okay. I have a data set of 1 lakh values. It's not a problem. It's not a big deal if I just remove those values out. But for a short data set, as in here, my data set is around 200 or 220 length of the data set. So for this kind of data set, cannot directly remove the values. In that case, we have to consider the mean on the basis of if we have those kind of continuous values. We have to plot a scatter plot, look at the values. If they are continuous enough or consistent enough, that we can consider the mean of the data, because if we have extreme outliers, the mean will be deviated. Or I might consider a median, or if the values are sorted, remember hear it again, if the values are sorted, I might consider putting in the value in the previous row or the next row, depending upon what kind of data I am dealing with. So there are a lot of decisions you have to make on the basis of data you have, by thinking over several factors while doing the analysis part. and it's really important. Most of the data scientists, according to an article, according to a report, or you can say many reports, there is even a meme or a quote about it, that most data scientists spend their 90% of time doing the exploratory data analysis. Why? The reason is because you have to derive a lot of insights over the data to actually or perfectly think about what should I use to predict, to build, to use a model. It has become really easy. I'm saying about the machine learning model. The machine learning models in Python are basically just importing your libraries, putting in your variables rightly, trying to check the metrics and do some stuff. It doesn't have a lot of steps considering, or say compared to what you perform in EDA. This is the first step and the most important step for any data science enthusiast, student, anyone trying to think about data science to understand. So I've given a brief lecture over here because I just want to highlight the importance of this exploratory data analysis step. And similarly, we can gain insights of other categorical variables. There's specialization variable, and then there's placement stats. Then you can see 69% of students have been placed for the college or university, whatever the data we are dealing about. And while the students who didn't get placed are 31%, which is like a good rate of placement actually. Yeah, so we can perform the data analysis on categorical variables. In this way we can derive insights, not just percentages. We can derive particular means, particular stats for that data. You can go out and plot several distributions plots for this, even the categorical data on the basis of their counts. And sorry, not distribution, I shouldn't use that word mostly for the categorical data, but try to understand the importance here. You can derive so many insights on the basis of a categorical variable by just using it from the data set, right? So you can get advanced with it by trying to look out for how to do EDA in more advanced way. Try to bring out more insights about it, try to do more work. Maybe if you learn some machine learning, you'll be able to do some more better EDA, because you can actually understand what you are doing or the purpose of doing this. And the next step is exploratory exploring exploring the continuous data. Now here we are considering the continuous variables, or variables having continuous values. There's SSC percentage, there's HSC percentage, there's degree percentage, there's e-test, MBA, salary, etc. Now let's just separate these columns out by creating another data frame with just continuous values, continuous variables, and you can check on its head. It shows just the continuous values. Now we'll be using the describe method to look at how our data set statistics show up. You can see the count of the data set for all variables except salary is 215, which is full, and the salary is just 148 because those are students who are placed. And there's mean. The mean percentage of SSC is 67. For HSC it's 66. Degree again 66. There's e-test, MBA. I can see there's a lot of stats about the mean. There's standard deviation if you need, because standard deviation is of utter importance when you try to use regression to predict your values, right? I hope you know regression. If you do, that's great. Then there is minimum value, that is the minimum value for each variable. For SSC it's 41 around. and for the HSC there's 37% as well. I guess 35% is the passing percentage for HSC, I don't know. Then there's degree percentage of minimum 50%, e-test 50, MBA 51, etc. Then these are 25%, 50%, 75%, basically quantile values Q1, Q2 and Q3 for each column, each variable. And then there's max, which is the maximum value for each column. So for SSC, max percentage is 89. For HSC, interestingly, is 97.7, while for degree there's 91, etc. You can just have a basic insight about the data from this describe method. What we did over here is separated our students who are placed from this data set and placed it into the data set called placed. So placed only has the students who are placed. Okay, and let's try to describe this data set. There's all 148 values. Then you can even view the mean, and you can find the difference here. The placed students have a slightly higher mean of SSC percentages, HSC percentages, even the degree percentages, I guess, by 2% marks, etc. Even the minimum percentages are low, etc. So you can just try to compare those, and even the standard deviations would remain same. Just for instance for the salary, but for other variables they will differ basically. Then we can also obtain the correlation table for these variables. Let's just type in this .corr method, and you can see for each variable there is a correlation with every other variable. So SSC with SSC is 1 correlation, SSC with HSC is 0.29, etc. And you can see in this particular table you can't view a single value having correlation value of more than 0.5, which is really sad. Okay, why? Or even below in the negative 0.5 or something. Correlation basically means if a value if a variable A is increasing, variable B is also increasing, or decreasing, it's decreasing on the basis of the correlation values. Okay, and we can see there's not a single variable actually affecting the salary to that extent. There's not a single variable having high correlation or very low correlation with the salary, and that's really weird, right? As we all say that scoring higher percentage would ensure a higher salary. Doesn't look like that. It's all the same. And you can go out and plot some distributions. If you know the concept of distributions have there are three types of kind of basic distributions. There's uniform distribution, which has just uniform I can't explain that. Try to look out for yourself. There's right-tailed, left-tailed distribution, there's uniform distribution. These three types of distributions, if you do know them, you will be seeing them here right now. If you don't, try to search for them, because I couldn't teach much of statistics to you because of lack of time. We can't go over 1 month of time, 2 months of time, right? This is the last video. So for now, this is a univariate distribution of salary. So you can see in this particular distribution, this is a right tail distribution. Why? The tail of this distribution is towards right direction, so it's called right tail distribution. And for this distribution, it looks like most of the people have the salary ranging between 22 lakhs to 4 lakhs, and you can see so less people having salaries above 4 lakhs. And this is the real scenario of the corporate world, is it? I don't know. Just try to look at the salary insights over here. Then there's another variable degree percentages, we can see the distribution for this particular variable looks pretty uniform. That is, there are most people having degree percentage of about 70 percentage, and this is properly distributed, that is uniformly distributed. While if you can see here, average looks like around 2.8 lakhs. Now for those who don't know this distributions, the mean is the value wherein there's a peak of the distribution. So here's the peak, it's around 2.5 lakhs or 2.8 lakhs for this particular distribution, and over here it's around 68 or something. You can see this peak is around 68, 67, right? You can also view that again. So many might have wondered how I plotted these things. There's again another plot, dist plot in the Seaborn library. Try to search it and go through the documentation. If you don't know, all you have to specify inside is the particular column of your data frame and just use plt.show. Now this just shows a distribution wherein you have a rug, you have KD. What is basically, it is a line covering this distribution, showing you easily where in your peak is actually lying, trying to cover up the distribution. I'm not going to explain what it actually means or what it doesn't. This is part of statistics. I am not going deep in it. And then there's again, we are trying to show the another insight over here, the another plot wherein I'm falsifying the KD. So I don't want to show the line, and I just want to show rug over here is basically these small lines below. You can see the more lines, the more is the distribution over there, or higher values kind of thing. Okay, can again plot some distributions for the next datas. There's HSC percentage, which again looks like pretty uniformly distributed, having a mean value of around 64, 65. Then there's SSC percentage, which is again uniformly distributed. MBA percentage, which is again uniformly distributed. Now there's the next form of plot, that is joint plot, which actually tries to plot two distributions. Here you can see there's one, there's two, and on the basis of those two distributions plots the points we have related to two variables. There's this is for HSC and this is for salary, and these are the points it has plotted. And it also tries to if we just specify kind is equal to reg, that is regression type, it also shows the line of regression passing through the points. But you can see, and also I have used the dot annotate method stats.pearson r to actually show the Pearson r value, that is correlation value, and then p value as well. If you know, that's great. If you just don't know, let's see. Now the stats.pearson r is from SciPy library I have imported before, if you remember it. Now in this particular data we have plotted the points. Basically they look like scatter points, right? Now you can see most of the people have the salaries clustered between 2 lakhs and 4 lakhs, or maybe a very few around 4.55 lakhs, and there are only 3 values above 6 lakhs and 8 lakhs. There's one value as well. So you can see maybe these are just the outliers, right? Think about it, if they should be taken as outliers or not. This is a job of a data analyst. So outlier, what a outlier basically means is a value exceeding the limit. And if you try to check on the quantile values for this particular variable, the salary, try to look at if these values qualify as outliers, and maybe just remove those values because they're affecting our mean, right? They sure are, isn't it? So these are few stats, and you can see, yeah, so most of the people don't get enough salary. And then there's degree to salary. So where in I plotted there's HSC percentage and salary, just just so you know that this is relative to HSC percentages. Okay, then there's again degree percentages relative to degree percentages. Then there's again I'm going to plot MBA percentages. Okay, so this kind of show you that most of the people have right percentages, like uh, around the average percentages, but they don't get enough salary. Okay, they don't get average salary every time. The average salary, or I'll say average salary, is too low. If you look at the right-tailed distribution here, you can see it looks a bit biased because salaries are too much crowded for 2 lakh to 4 lakh interval, right? And most of the salaries are just too low for head, while our data shows that most of the people do have enough degree percentages, enough HSC percentages, enough SSC percentages, MBA percentages. So hey, these percentages don't matter for salary, right? And you can even see from the correlation table that most of the variables, or almost all variables, just don't have enough correlation with the salary as a column, as a variable, which is really sad to look at because hey, more the MBA percentage, more should be the salary, or more the HSC or degree percentage, more should be the salary, right? But our data doesn't look like that. Every person has got the same kind of salary value between the interval. There's 2 lakh and 4.5 lakh on the basis of our data, and sadly that's our insight we can derive from this data right now, for now, on the basis of our exploratory data analysis we have performed till now. So do you think we should be removing outliers? If you do, try to work on it. I'll be sharing this notebook on the GitHub, on my GitHub account. I'll be putting the link in the description down below, and try to go and remove some outliers and look at your data, and maybe derive some more insights about the data based on if a student is placed, should his salary be enough for him, etc. Okay, that was some nonsense. Okay, think about it by yourself, try to analyze yourself from your point of view, and try to put in your solutions below this particular notebook. I'll be sharing this, and this was all about EDA for this last video. I hope you have again enjoyed your journey through this training program, and I hope you'll be interested again to go through the next training program, that is machine learning, which will be taught by my senior Harshmit Singh, and it's going to be really interesting. Try to go through it so that you can use this EDA to go ahead and predict values for certain variables, which would be really interesting, right? Thank you for being with us.